All right, in this video, I'm going to go over one-to-one functions and using the vertical and horizontal line tests to tell if a set is a function or a one-to-one function. All right, but first I'm going to review what functions are. So we have this question: is the letter grade you earn in class a function of the percent grade? First of all, what are they asking here? If something is a function of something else, that means it's its output, right? So letter grade would be the output. And the percent grade would be the input, right? So let's just say L for letter grade, percent symbol for our input equals, whatever, something percent. That is the function we're looking at, kind of like f of x equals x minus c or x plus c, whatever. C stands for constant, so it could be any number, 7, 10, negative 24. So we're asking, if you input a percent grade and you get out a letter grade, is that a function? Well, what's the definition of a function that we're reviewing here? It means you put in one thing and you get out exactly one output. And that is true for this. You get out 98, you get A. If you put in 98, you're always going to get an A. If you if you get a 79 in your class, you're always going to get a C. If you get a 79 in another class, you'll get a C, unless they, grade on a curve. Then you might get bounced up to A even if you get a 79. But yes, this is a function. Yes, it is a function. Every input has exactly one output. All right, so now that we've reviewed that, what does it mean if it's one-to-one? Is it a one-to-one function? Now, what a one-to-one function is kind of like flipped the rules of a function. See, we can have all these different inputs and still get that same output, right? And it's still a function, just so long as we don't have that same input giving us a different letter grade. You can't get an A if you got an 89, If you got an 89.9, I suppose you'd have to round up to an A, but we're not getting that far and that deep into it. That's not what this does. So what is this one-to-one? What is it? It is not one-to-one, because it's kind of asking, like, if we go the other way and say this is the input, then it's not a function, right? Is the percent grade a function of the letter grade? No. And that means it is not one-to-one. I believe that's how they abbreviate one-to-one. If not, your teacher might insist that you always write out 1-to-1 like that, which is understandable because this could be mistaken for something else. I don't know. Brackets and a dash. So what would be both a function and a one-to-one function? Well, that would be your simple line equation, like f of x equals 3x plus 2. Not 3x and 2, it's 3x plus 2. Yeah, one for every one input, there's only one output. And for all the inputs that you put in, you'll never get the same output. You put in 0, you get out 2, you put in 1, you get out 5, you put in -1, you get out -1. You know, it just goes on and on. And so, all right, here are a couple more examples in case you didn't get it the first example. Let's just focus on this one first, f of x. We put in all these numbers and we get all these numbers, right? Do any of these inputs repeat? No, they're all different numbers, right? So it's definitely a function. So yeah, function, check. Does it need to be a function to be one-to-one? No, I don't think it does. But we'll go over that later with the vertical and horizontal line tests. Do any of their outputs repeat? No, they're all different. So this is one-to-one. It's both. What about this one? Function, none of our inputs repeat. So yep, that's a function. What about our outputs? 3, 1, 0, 1, 3. Whoa, okay, we got 3s, 1s. Yeah, our outputs definitely repeat. We put in -2, we get a 3. We put in +2, we get a 3. So is this one-to-one? No. All right, this last part is my favorite part. We've been looking at data sets with tables so far, right? And you have to, look at the numbers to figure out if it's repeating any of those numbers. And that's pretty simple. But what happens when we have a graph? Well, first of all, you'll notice I don't have any of the names of these sets anywhere. I don't have f of x anywhere. We're not doing that right now. All we're doing is using the vertical line test to figure out which of these is a function. So the vertical line test means you can put a vertical line anywhere you want on the graph. Anywhere you want. Anywhere. So imagine there's vertical lines everywhere because, well, there are. And if that vertical line, if there's nowhere on that graph when any vertical line that you could possibly draw touches the graph twice, if it never does, then it is a function. Function? Yes. So we'll just do that for all of them, right? This one, we can put vertical lines anywhere we want. It's never going to hit this line twice, so that is a function. All right, what about this one? You see, now we're hitting it in 2 points. That means that for this one output, which is the x axis, right, there are two for this input, there are two different outputs, which is not a function, right? So not a function. Make sense? It really is that simple. Circle, yeah, there's all sorts of vertical lines here that cross the circle at two different points, so it's not a function. Here, we kind of got a S-shaped. We got vertical lines that cross the graph at three different points. So it's not a function, clearly. It's a little extra crazy. This one, well, this one we can never find a vertical line that crosses this graph twice. So yes, this is a function. It really is that easy. All right, now what about one-to-one? How can we tell if a graph is one-to-one just by looking at it? Well, this is where the horizontal line test comes in, because it's kind of the the reciprocal of the vertical line test. We're just kind of switching it to this way. If we have two different outputs now, let me just get a different color marker for this. We have two different outputs, or two different inputs giving us the same output, right? Because the y-axis is the output axis, and those are the same y value. Even though they're completely two different points, they have the same y value. So that is not one-to-one. It's that simple. About this line here, no horizontal line will ever cross this graph twice, so that is one-to-one. So we have an example of something that is a function but not one-to-one, and something that is a function and is one-to-one. Yep. All right, what about this one? Horizontal line test. Well, this one is like a parabola just flipped on the side, right? So yes, that is one-to-one. There's no horizontal line that you can draw that will cross the graph twice. All right, what about the circle here? Nah, that crosses twice for sure. Not one-to-one. So we have an example of something that is neither. It's not one-to-one or a function. That's a circle. Circles are weird. All right, what about this one? This is an S shape, but I think it passes the horizontal line test for sure. Yep. Just keeps going like that. So that's not a function, but it is one-to-one. And this one is just the reciprocal of that, right? So, or the inverse, I should say. So it fails. The horizontal line test is not one-to-one. So I think we've got at least an example of every possibility. Something that is a function but not one-to-one. Something that is a function and one-to-one. Something that is not a function but is one-to-one. Something that's not a function or one-to-one. And something that is not a function but is one-to-one. Oh, already had one of those. And something that is a function, not one of them. I already had one of those too. Well, I suppose I should stop talking now. Thanks for watching. If you made it this far, you deserve a cupcake.